All right, y'all. So I'm so excited that we have finally learned the background of chemistry, that we can finally start talking about how these things are going to react. So just as an introduction to this unit, we're going to breeze through the types of reactions that we are going to be learning for chemistry for this year. Please know there's lots of different types of reactions that can actually happen in the world. We are studying 5 right now, and that's it, okay? But again, there are lots of different kinds that can actually happen. So let's go ahead and get started and look at the 5 we're talking about. Okay, so what you can see here, these are the 5 that we will be looking at. Let's go ahead and start off with synthesis. Okay, so synthesis is actually also called combination reaction sometimes. So if you use anything online, you might hear both. Okay, synthesis and combination. So the word synthesis should make you think about synthesizing, which involves like making, putting together, a mashup, kind of all of those words. And so what you can see here is that you have 2 reactants turning into 1 product. Okay, so that is the big deal for synthesis. So for each of these, I'm going to give you your hint to the type of reaction. Okay, and so for your hint for synthesis, it's going to be 2 elements as the reactants. Okay, so here's just a look at some examples. Don't worry about these big numbers in front. We are going to be learning about those next. Okay, but just focus on the fact that you have cesium and oxygen combining to form cesium oxide. Magnesium and sulfur making magnesium sulfide, aluminum and chlorine going ahead to make aluminum chloride. One thing that I do think you should take a note of right here in your notes is looking at why this is O2 and Cl2. Those are our diatomics. So go ahead and just make note. Don't forget your diatomics here. All right, so for each of these different reactions, I'm going to give you a scenario. So this one's called the perfect match. In the dating game, all right, so you have 2 young souls who come together to make a couple, all right, and so that is our synthesis reaction. So again, one last time, you have 2 things combining to form 1 product, and your hint is that it is 2 elements as your reactants. On the other side of synthesis, we have something called decomposition. So the word decomposition, right, that should make you think about decomposing, breaking down, right? These are words that we've heard of before. So for our decomposition reaction, you're going to start with 1 compound that is then going to split into its elements, okay? So your clue, your hint for this type of reaction is that it's always going to be 1 compound as your reactant, okay? So here are some examples with some real chemicals. You've got calcium oxide. Oops, sorry about that. You've got calcium oxide breaking down to calcium and oxygen, water breaking down into hydrogen and oxygen, and then we've got lithium sulfide decomposing into lithium and sulfur. Again, good idea just to take note, give a little circle, give a little reminder in your notes, pay attention to those diatomics, okay? And so then in our dating world, the last one was the perfect match, but here, it's the breakup, okay? You've got your 1 compound breaking up into those 2 pieces. So again, your recap, you're starting with 1 compound, it breaks into 2 parts, don't forget your diatomics, okay? And then your clue for the type of reaction is that it is 1 compound. All right. Single replacement. So this one looks scary, but it's not. It involves like 1 extra thought compared to the others. So single replacement, it's called single because you have something that's by itself. That is single, okay? So here we have our single element being called C. And then replacement, right? That word should make you think about replacing, switching, taking the place of, right? And so for our single replacement reaction, C, our thing that's by itself, is going to switch or replace something in the compound it is reacting with. Now, the reason this one has 2 scenarios is because if your thing by itself, your C, is an anion, well then it switches with the anion of the compound, okay? So remember that when we write formulas, we've got A, B, typically a cation, then an anion. So then if our thing by itself, our C, is an anion, well it switches with the anion. And if a thing by itself is a cation, then it switches with the cation, okay? And so you do have to just like take a beat, take a second and think about, okay, is that thing by itself a cation or an anion? It's only one that has just that extra little thought to it, okay? So, cation. We'll fix that to say cation. Actually, I think it is there. It's just too small. Let's see. All right. So, when you are doing these, okay, your clue, your hint to the type of reaction is that it's going to be a compound reacting with one element. Okay, so a compound reacting with one element is forming these single replacement reactions. Also, pay attention to diatomics here because you do have some things by themselves. This is a really good place for me to put those diatomics in. All right, so here are some examples. You have lithium with calcium oxide. So because lithium is a cation, it's going to switch with calcium. So now calcium is by itself and lithium is part of the formula. Over here we have H2O plus nitrogen. Nitrogen is an anion, so it is switching places with the oxygen. So now hydrogen and nitrogen are together, oxygen's by itself. Then over here we have lithium sulfite reacting with magnesium. Magnesium is a cation, so it's going to switch with the lithium. So now lithium is alone, and the magnesium sulfite, they are together. So we call this one the do-si-do. Oh, there we go. The cut-in. And so the cut-in, right, you think about it, you've got a couple dancing, and then someone taps in and makes the switch. You could also call it the switch-up, but that is what we are looking at for this ridiculous analogy. So again, wrapping that one up, your single replacement reactions is a compound reacting with a single, there it is, element. All right, and so your clue, looking for a compound with a single element, just a little asterisk, take note if that single thing is a cation or an anion. Next up is the double replacement reactions. So double replacement, it's called double, not because two things switch. So this is what happens sometimes with students is they get a little bit confused and switch everything. Don't do that. The word double is because it's double compounds, okay? And so your reactants, you've got two compounds here. You can switch to the anions or the cations. It's a personal preference. I'm just demonstrating here by switching to the anions because I have found that's what students do the most. But if you're a cation switcher, go for it. Doesn't matter. Okay? But the idea is that you are going to switch either the cations or the anions from one compound to another. So you can see here I switched B and D. So now A and D are together and C and B are together. So your clue for this type of reaction is that it is going to be two compounds. All right, so here are some examples worked out. And so you can see here the lithium sulfide reacts with the calcium oxide. So I switched the lithium and the calcium in this example. And so now calcium is with sulfur and lithium is with oxygen. Let's just go ahead and make this fit better on one line. There we go. It's easier to see. All right. So in this example, we've got cesium carbonate with aluminum nitride. I'm going to switch the carbonate and the nitrogen in this example. And so you can see now the cesium is with the nitrogen and the aluminum is with the carbonate. So again, you can switch either the cations or the anions. I gave you an example doing both. It doesn't matter. You will end up with the same final answer in the end, okay? So again, this one is called the do-si-do, where everybody is switching around what is happening in this type of reaction. And so you can see you've got one couple on the left, one couple all on the right, and then the blue shirt switches with the green shirt, okay? And then we are left with a new product, okay? So that is what is happening here, okay? And so for our recap, you've got two compounds reacting to create two new compounds where either the cations or the anions are going to switch place, okay? And so your hint, your clue for this type of reaction is that it is going to be two compounds, okay? The last type of reaction that we are going to study is called combustion. And so combustion is everyone's favorite. Combustion should make you think about explosions, right? Okay, so combusting, if you ever have seen a fire, okay, or thought about fire, every fire needs oxygen, okay, in order. So that's like how fire eaters work, right? Like they put the fire in their mouth, they close their mouths. It takes away the oxygen, and that makes the fire go out. So one of our reactants for combustion is always going to be oxygen. And then our other reactant over here, this CXHY, is a fuel. Okay, there's lots of different fuels. You've probably heard of propane, right? If you have a gas grill, you probably have a propane tank. There's octane is also one that people have heard of, ethane, methane. These are all examples of fuels. And if you go on to take organic chemistry, you will learn all of those in great detail. But the deal with fuels is they all contain carbon and hydrogen, okay, in some sort of ratio. So those little numbers, that X and Y, they can change. Then what's awesome about combustion is you don't have to do anything complicated and think about writing formulas and think about diatomics or think about switching products. Nothing. The products are always carbon dioxide and water. Okay, every single time, carbon dioxide and water. So what you're going to want to do for these, your hint, okay, your hint is pretty straightforward. You're going to see CXHY, so it'll say like C2H8. Okay, you're going to see a fuel plus oxygen every time. And then these are the easiest because they will always, always, always create carbon dioxide and water. So here are your examples. So that's what I was saying about those little numbers changing, your little subscripts. So this first one, this is ethene, this is pentane. I will always give you the formula for your fuel, okay? And so here's your fuel reacting with oxygen, and then you can see every single time the products are going to be carbon dioxide and water every time. And that's it. Those are the 5 reactions that we need to learn. And so now what you're going to do is take some time, flip through this summary, and we're going to go ahead and ask any questions that you might have. So here we go.